All right, when we have absolute value in equations, first step is to isolate the absolute value. Second step is to do the split. Isolate absolute value. Second is the split for equals and then opposites. All right, this one is the absolute value isolated. Yes, it is. So we automatically do the split. 2 plus p equals 4. And then my opposites. 2 plus p equals negative 4. There are two equations we can solve now. Subtract 2. That's not a 2. P equals 2. Again, subtract 2. P equals negative 6. Two answers. Good. Done. Is the absolute value isolated? No, it's not. Add 2 to both sides. Absolute value, negative 9n equals 18. Hey, should we change this negative 9 to a positive because it's inside absolute value? No, we do not change things to a positive unless we're taking the absolute value. We can't take the absolute value. There's a variable inside, so we have to solve it with the steps we learned. Isolate the absolute value and then split to equals and opposites. So here we have isolated the absolute value. Now we have our equals equation, which means we write it exactly how it is with no absolute value, and then the opposites equation, which means we write the absolute value part with no absolute value, and then whatever's on the right side of the equation or the side that didn't have the absolute value, we make negative. Now we can solve and get our two answers. N is equal to negative 2, and n is equal to positive 2. All right, there's a negative 6 in front of this absolute value. Now we do not add 6 because this negative 6 is right next to the absolute value symbol. That means negative 6 is timesing by the absolute value. If they're timesing by the absolute value, the inverse operation would be to divide. Divide by negative 6 on both sides. You have to do this before you do the split because you have to isolate the absolute value before you do the split. And we get 19. All right, now we can do the split. Negative 1 plus 9k equals 19. Negative 1 plus 9k equals negative 19. And you get your two answers from there. I hope you can do that. I think you can do that without me. Moving on. 23. Linear inequalities. These are actually pretty self-explanatory. I am going to do number 26 though. So let's get the x's to the same side. So I'm going to subtract 5x from both sides. And I get negative 2 is greater than negative 2. Again, no more variables, so we ask ourselves, is it a true statement? If so, all real numbers is our answer. And if it's not a true statement, then no solution. Is negative 2 greater than negative 2? No, it's equal to it, but it's not greater than. So that would be no solution. All right. Solve each compound inequality, graph its solution, make your own graph with brackets and parentheses, write your answer in interval notation. Very important. So we have a compound inequality going on here. So almost like two equal signs. You got a left side, a center, and a right side. We do each operation to all three sections. So if you would add 2, you add 2 on the left side, and you add 2 on the right side. So you have negative 6 is less than, n is less than or equal to, remember to keep those signs consistent with what they were before, 4, negative 6 to 4. Great, so I'm going to draw a number line, a lazy number line, because that's all I need, negative 6, 4. This is an and, so it's one interval. They're facing each other. On the negative 6, I should have parentheses, because there's no line under here. There is a line here, so there should be brackets on the 4. Now I shade in between. The interval for which that contains the solution set for this problem is negative 6 to 4. And you already know what to put around it because you put it on the number line. Continuing on. Two separate ones, two intervals. This is an or statement. Get it? Or. Okay, this is an or statement, so solve separately. So minus 2 on each side. P is less than or equal to 2. And then minus 3 on each side. P is greater than 6. Okay, So now I have a split interval, so we're going to have 6 and 2. This one's going to open this way. This one's going to open this way. So less than or equal to. So on the 2, we have a bracket. On the 6, we have a parenthesis. Shade outward. And that is written as negative infinity to 2, union 6 to infinity. Remember, furthest to the left is negative infinity, furthest to the right is positive infinity. 2 important points, and then union between. Okay, what in the world is happening on 29? So again, this is an and statement, one interval. You have 3 sections. Subtract 6 on both sides, and you get negative 63 is less than or equal to negative 7k is less than 50. Sorry, we're going down, so 35. It's been a long day. All right, we're going to divide everything by negative 7. Divide by negative 7. Divide by negative 7. Oh my gosh. We now need to flip all these inequalities, okay? So this becomes greater than or equal to. This becomes greater than. And this is a 9. This is k. And this is negative 5. But I told you when you write an and, a compound inequality, an and statement, it has to be smallest to greatest. And the little inequality symbols are always going to be facing, sorry, you can't see my hand, it's too big for this video, it's always going to be facing this way. Okay, it's always got to be facing this way. So we just need to write this so that it's written correctly. So the smallest value is negative 5. This symbol goes here, k. This symbol goes here. Again, now they're both facing this way. Again, it can include 9, so make sure that one's over here. But we literally just like took this and flipped it over. All right. You've got negative 5 and you've got 9. You've got a parenthesis on negative 5 and a bracket on 9, and it's one interval. Parenthesis, bracket, shade in between, write it as an interval, negative 5, comma 9, put a bracket on the 9, parentheses on the negative 5. I'm going to let you do 30 on your own. Moving on to absolute value inequality. We talked about this. We just learned this yesterday, didn't we? All right. First of all, isolate absolute value, then write as an and or an or statement, and then solve just like you did these. Okay, so first step, isolate the absolute value. That's my lazy way of saying absolute value of something. I don't know what's inside, but whatever, who cares? And then step 2, and or. And write it accordingly. All right. I'm going to do 33 and 34 because they look like the harder versions. All right. First, isolate the absolute value state. So we're going to, 9 is being times by the absolute value. So we divide both sides by 9. Is the absolute value isolated? Yes. Is this an and statement or an or statement? Greater than means it's an or statement. So write it as separate. Negative 9p minus 5 is greater than 5. Negative 9p minus 5. Flip the inequality. Change the sign of the 5. Solve. Negative 9p greater than 10. Divide by negative 9. Divide by negative 9. All right, so now when you divide by negative, we've got to flip the inequality. Ooh, we had to do, remember, lots of crazy things in this one. I'll put it as negative 10 over 9. Fractions, again, are better than decimals. often more precise. Add 5, negative 9p less than 0. Divide by negative 9. Divide by negative 9. P is, flip that inequality again. You divide it by negative 9 is equal to, is there a solution to this? Yes, there is. 0 divided by negative 9 is 0. Okay? Don't just think when you see a 0 that, oh no, that means no solution. Okay? 0 can actually be an answer. So now we're going to graph it just to help us with interval notation. So negative 10 over 9, I'm going to put that into the calculator just to get a decimal just for graphing. So that's about 1.1. So this is about negative 1.1. So let's put, okay. So at negative 1.1, that's an important point. 0 is an important point. Okay. 2 separate intervals, opposite directions, both parentheses, facing outward. So parentheses, parentheses, and then shade. My shading is real pretty. Okay. And then write in interval notation. They did not tell you to write it in interval notation, but I will be telling you to write it like that on the test. So make sure you can write it in interval notation. So from negative infinity up to negative 10 over 9, union 0 to infinity. Okay. And we're going to do 34. Okay, is the absolute value isolated? No, it is not. So I need to add 5 to both sides. So absolute value 10 plus 3x is equal to, sorry, so used to writing equals, less than 31. All right, now that the absolute value is isolated, we can make the split. Oh, it's not a split. No, sorry. Jumped back in and I forgot what we were doing. Okay, first we isolate the absolute value. Then we ask, is it an and or statement? This is an and statement. So instead of splitting, we write it all as one. We drop this down. 10 plus 3x less than 31. But it's also greater than negative 31. That's how we write our and statement. Solve it just like we were before. So minus 10. Negative 41 is less than 3x is less than 21. Divide all parts by 3. This fraction does not reduce, so just leave it as negative 41 over 3 is less than x is less than, and that is 7. All right, both parentheses facing each other, one interval, so 41 over 3 is about 14. So let's go to around negative 14. We'll put the parentheses, again facing each other, so then the 7. And shade between. To write it in interval notation, we just have to write one interval. Negative 41 over 3, comma 7. All right. Solve each equation by factoring. This is the bonus for the test. So it's not required, but if you watch how I do it, then you can probably do it on the test and get some extra credit points. All right. Here, we need two numbers that multiply to give me negative 3. And those exact same two numbers need to add up to give me negative 2. So multiply to give me the last number, add to give me the middle number. All right, the only things that multiply to give me 3 are 1 and 3. In order to add to give me negative 2, the 3 will be negative and the 1 will be positive. So I have x times x gives me that x squared. Drop the 1 and the negative 3, so plus 1, negative 3. Again, drop the equals 0. Done factoring. But they asked us to solve. So if this times this is 0, then use the 0 product property, stating that if something times something else is 0, then one of these or both of these have to be 0. So x plus 1 equals 0. X minus 3 equals 0. So x could equal negative 1, or x could equal positive 3. And those are your two answers. The next one is a little bit different, just because there's a number in front of this squared term. So I'm going to show you my method. If you like to see other methods, I have other factoring methods on this YouTube channel. All right, so two things that multiply to give me 5p squared. So 5p and p. Two things that multiply to give me negative 12. I'm going to pick my signs later. So I'm going to say 4 and 3. 5p and 4, I'm going to be putting into the same parentheses if it works out. And p and 3, I'm going to put in the same parentheses also if it works out. So to test, I need to multiply across the parentheses. I need to multiply diagonally. So 5p times 3, that's 15p. P times 4, that's 4p. This is just testing. We're not going to actually use this for the factoring. We're using this just to check, see if this is correct. Now, these two things need to give me my middle term, negative 11p. Can they? Now remember, two things multiply to give me negative 12. One of these has to be negative. So if one of these is negative, can I add to get negative 11p? Yes, I can. The 15 has to be negative, and the 4 has to be positive. So p times 4 gives me 4p. This 4 has to be positive. So we'll put the plus in front of that 4 because it's going to be a positive 4. But 5p times 3 gives me negative 15p. That means this 3 needs to be negative. All right. So here's what goes in the first parentheses. Here's what goes in the second. 5p plus 4 times p minus 3 equals 0. Use the 0 product property to solve. 5p plus 4 equals 0. P minus 3 equals 0. So p could equal positive 3. And then here you're going to get a fraction. So you'll subtract 4 on both sides. 5p equals negative 4. Divide by 5. Divide by 5. P equals negative 4 over 5. And that gives me my two answers.